Okay, now we're going to look at distributing with radicals or with square roots. So our first thing that we're going to look at here is we're going to simplify the square root of 5 times the quantity of the square root of 3 minus the square root of 75. There are two strategies or methods that we're going to look at of how to simplify this one. The first method that we're going to do is actually start by distributing. Let's multiply the square root of 5 times the square root of 3. Remember, the number under multiplies with the number under. And then we can multiply the square root of 5 times negative or minus the square root of 75. So when we multiply them, 5 times 3 becomes the square root of 15, and 5 times 75 becomes the square root of 75. Now, if I wanted to subtract these or combine these, I could not because they do not have the same radicand. But I can simplify. 375 does have a perfect square factor. So let's find the biggest perfect square factor inside of 375, which is 25. 25 times 15 is 375. Let's take the 25 out by taking the square root of it, so it becomes 5 square root of 15. Now these are like terms because they have the same radicand. Let's combine the numbers in front. Remember, in front of this first one is really a 1. So I'm going to group together the 1 and the minus 5, and that gets multiplied the square root of 15. Let's subtract, and I get negative 4 times the square root of 15. So that's one method. Let's look at a second method. The second method is to simplify inside the parentheses first. Again, these cannot be combined because they don't have the same radicand, but 75 does have a perfect square factor, which would be 25. So if I break up 75 to be 25 times 3, I can take the square root of 25 to give me 5 and the square root of 3. Now inside of this parentheses, now these are like terms and I can combine them. We're going to look at the 1 in front of this radical 3 and the minus 5 in front of the second radical 3. They are going to be combined. 1 minus 5 is going to give us negative 4 radical 3. Now notice how this radical 5 has been hanging out in front the whole time. Now we're going to actually multiply these together. Remember, underneath goes with underneath, so we can multiply the 5 and the 3 together. Technically, there's a 1 in front of this radical 5, and the 1 is what gets multiplied by this negative 4. So now we're going to get negative 4 times the square root of 15, which is exactly what we got in this first method. So that's up to you to decide what method you prefer, if you want to simplify in the parentheses first, or if you want to distribute first and then simplify, that's up to you. Let's look at another example and let's listen to Big Ideas explain it.
Simplify the square root of 7 times the quantity the square root of 3 plus the square root of 48. First, use the distributive property to rewrite the expression as the square root of 7 times the square root of 3 plus the square root of 7 times the square root of 48. Next, use the product property of square roots to write the expression as the square root of 21 plus the square root of 336. Next, factor using the greatest perfect square factor. Notice that the greatest perfect square factor of 336 is 16. So the expression can be rewritten as the square root of 21 plus the square root of the quantity 16 times 21. Next, use the product property of square roots to write the expression as the square root of 21 plus the square root of 16 times the square root of 21. Because the square root of 16 equals 4, the expression simplifies to the square root of 21 plus 4 times the square root of 21. Next, use the distributive property to write the expression as the quantity 1 plus 4 times the square root of 21. Because 1 plus 4 equals 5, the expression simplifies to 5 times the square root of 21.